So as Todd said, I am Chris White. I'm the WC DevOps Coordinator, which is a fairly new role, and I'm here to talk about implementing a security-conscious build configuration relay with a shared build cache, which is a shortened title from my last time I gave this. So, as regular, I work for Lawrence Livermore. WSC pays me. We do much work under the auspices of the DOE. So what is WSC? WSC is a program that develops these multi-physics simulation applications. There's roughly about 120 developers of multiple different amounts. They are physicists, engineers, computer scientists, software quality, engineers. There's all sorts of different types of them. There's roughly about 15 project teams inside of WSC, but we depend on a lot more across the lab. There's roughly about 30 of them that we depend on. And our codes live for a very, very long time, anywhere from 15 to 30, 40 years, like AL3D. And it's a diversity of programming languages and HPC architectures. We code in C++ and C, in Fortran, Python, Lua, and of course, you all know we have distributed memory across multiple cores and a diversity of data. There's some pretty pictures that I don't generate and I never see. So what is a multi-physics simulation? The rest of the code may also call this an integrated code. So the reason why this is kind of hard, the reason I have this slide is to show why is this complicated and why do we need to go through this giant hoop. So we have this a button here maybe. Okay, so we have this, a multi-physics code is broken into a bunch of different parts, but we also have everything underneath as well. So we may have input parsing, code steering, the communication, logging and stuff, in situ coupling, but we also have all the physics packages, all the material stuff. I'm not a physicist, so, and then we have all the math stuff as well. But when we take, after we build the code, we also have all how we use it as well. So we have problem setup and meshing, visualization, uncertainty qualification, and just managing all of this data and simulation, whether it's a workflow and everything. So what does this turn into? A ton of libraries. Some of our codes depend on 100+ libraries across multiple different systems, across multiple different compilers, and that is a nightmare to maintain. But what this talk is trying to explain is that while we have these codes that are upstream, these decisions that are made by these integrated codes influence the work of our upstream libraries like Axum and BLT and everything like that. So what do we need? Of course, our contractually obligated AI-generated picture. We need to improve communication because we have these extremely complicated build configurations, and with my hat on as an Axum developer, I need to know as I'm doing my development work that I'm not breaking the important person, which is Marble or Ares or AL3D or whatever, right? Because that's the reason I exist. And how do we do this currently? It's by word of mouth or by guessing. And of course, that is not the entire pie. They give me, one little slice. And so, and of course, after they've given me that pie, it's out of date immediately because they don't tell me again. So I want all the information. So you can imagine I'm an Axum developer. I go to the Marble team. I say, hey, how are you building Axum? And they say, well, we're building this version with MPI and a compiler. You can tell that when you concretize this is not the information, and this isn't even all the information. So I need all of this to make sure that when I do my development work at Axum, that I'm not breaking Marble. You all use Spack. This was for a different audience. I assume no one wants me to explain Spack terminology. So another problem that we have is that we have a plethora of package repositories. So you can, we have a bunch of integrated codes, we have libraries, And all of these Spack Package Repositories, so we may have some project-specific ones. We have the new one that I created, because of course you got to create another one before you solve another problem. So we have the WSC one, we have the radius one, we have the Spack built-in one. And you can see, like, this is a nightmare. And so what we're trying to do is minimize this down to one project-specific one, and then maybe just this one, and we'll see if we can get rid of this one, or just not use it, and have this one as well. So we're trying to minimize the chaos. And this, it's not even the problem that all of these exist. Like, they're using different points in history in all of these package repositories. They may have different patches and fixes. Their environments may be different. And so all this is just chaos. So we're trying to fix that. So our goal is to ensure that our upstream projects, as I talked about before, can build against these pre-built and correct configurations. So we have these downstream projects. These are the integrated codes, whether they're integrated code or a library. We're building this thing called a configuration relay. So it lives inside of these important projects. It grabs the information out of their build of how they're building with Spack. It filters it. It chucks it into TPL build farm, which, to make a hard thing simple, outputs these library build sets. And then we have these upstream projects. Wherever they live, they can build against those pre-built libraries. So we are unique in many ways that we have restricted projects, but they may live in the restricted zone or the CZ zone or the GitHub. Wherever their dependencies are, they can now build against these pre-built libraries and ensure that they are not breaking everyone. Of course, this scares managers and security people. So what we are doing is we are making sure that the project source is kept in appropriate zones and inside of their project repositories. So just because you're on the RZ doesn't mean you get access to all the projects that are on the RZ. And so we are ensuring there's multiple automated and manual safeguards to make sure that those never leave, and that eventually there's also a human in the loop. So we're going to automate as much as we can, but there always will be a person clicking the button. And the related information, it's very important that it's human readable. I don't want to jump a bunch of hashes or YAML files that I can't read. It needs to be something that I can understand looking at it in a PR. And you guys all know this, but managers don't. Specs, concretization, environments, and recipes do not include project source. So that does not get relayed in the configuration relay. So what does this look like? A very complicated system. So we have the RZ and the CZ and the GitHub over here. So the pathway starts at a code, integrated code, and inside of this project config relay, which lives in their repo and they control. We're just giving them kind of templates of how we want it to look. It then filters this information out. It sticks it in the package repo that's on the RZ. This is build farm. It then outputs either like an upstream or a file system, whatever we want to do. And then those codes can also use those. It benefits them as well. They can use the build cache that exists, speed up their builds. But they can also share it with the libraries that are on the RZ and stuff like that. This information then just gets relayed again. It goes into a filtered config. There's an audit pipeline to make sure basically it doesn't have access to anything in here or any source code repos, so that when it does eventually go to the CZ, we didn't accidentally move a project. It's then read by a person, and it's automated over to this the CZ area. It's built again. The reason this is really important that it goes over to the CZ is that we have Axum, Raja, Umpire. We have a bunch of open source projects, and these are needed over here. But so Axum, I feel like I'm losing my microphone. Sorry. Axum does all its development in open source on GitHub, and every pull request that we do has pipelines that we test that are supposed to mimic this. Again, what I said, they're not really the whole picture. The idea is that by the time it gets over here, Axum won't have to build its libraries. They'll be ready for them to go. Exactly what came out of Marble, and it'll be tested on LC. So that's as good as we're going to get. That's going to be 100% is what I say. And so as Axum is doing their development, they're ensuring they're not breaking Marble. So what is a configuration relay? It's a process for moving and filtering these build configuration relays. I feel like I've said this a lot. It's never source, never binaries. We do filtering through an allow list. So you can imagine, it's not really important. There's two different relays. There's one from project to the shared and RZ to CC. So we have this allow list filtering. We have this spec. We have a compiler, which of course is now out of date. We need to convert to the new way. It's then filtered, and you take all these ones. So like Blast is a project-specific package. So is EXO, Silo, and all that stuff. And it's allow list filtered, and it's kind of flattened and expanded. So then we have this filtered version with all the information that we need as well, and it goes into the RZ. We are heavily leveraging Spack CI. This has gone really well for us. It builds everything in parallel. It deploys to the build cache. It was shocking few amount of lines of code. We also have implemented that people can put up a PR and it doesn't pollute the main build cache. It builds in a very PR-specific build cache before it's approved, and then once it's approved, it goes into that. Thank you, Alec, for helping us with that. That's been scared me from the moment I put that in until we actually got that deployed. We also use Spack and GitLab CI pipelines to implement this filtering. So we have this like mappings file, and we say like, okay, we have some environment. It's got a name that no one cares about. And then you say, okay, this is what's allowed. You have Axum, Camp, Chai, the ones that are in the open source, obviously. And this audit pipeline creates the environment, audits it, and has no access to the RZ Spack recipes. So if we accidentally, put marble here or whatever, obviously that would be stupid, but it would fail in this. And that's my talk.
All right, let's thank our speaker. Okay, I think we have time for a question while the next speaker sets up. So, all right, Andy.
Thank you. You obviously have a very specific use case for a very specific set of security requirements. My hunch is that there's a wider use case for this if people were going to be deploying, Spack infrastructure to populate build caches out in the wild, etc. Even if your primary concern wasn't security, but your primary concern was sort of isolation of various phases of the process. Do you think that's
fundamentally this is isolating proprietary software to stay where it should.
Okay.
And then also sharing, everyone depends on something else. You want to make sure your dependencies don't break you. So It's nice to share those important configuration relays. So yeah, that's.
Even if it was all open source, it seems like there's probably some lessons to be learned from this process for exactly that, for being able to reliably build things without weird dependencies creeping in and assumptions.
Right.
Thank you.
Let's thank Chris one more time.